السلام عليكم ورحمة الله وبركاته بناتي وأولادي الأعزاء. I am Mrs. Wafa. I am the mathematics teacher. I will teach you for this year the mathematics course, and I hope from you to be hard worker all over the term in order to score a high level. Okay? أول حاجة أنا عايزة أتكلم معاكم. The mathematics course is consisting of two branches. I have two branches. The first branch is algebra and geometry. The first branch is algebra and statistics. اللي هي statistics دي اللي هي tables والcharts والحاجات دي. And the second part is the geometry, the plane geometry. يعني we draw in a plane, okay, not outside, not solid, not 3D. Let us start today for the first lesson, for the first branch. So mathematics. This year consists of two branches, first and second. The first part is algebra and statistics. Algebra and statistics is the first branch. The second branch is the geometry, plane geometry. It's the geometry. This is the second branch. Okay? This is the second branch. We shall start today in the first branch, which is the algebra. Algebra is simple and very funny. We see problems in life. Let us see at first the chapter 1. We shall start chapter 1 in algebra. I start now the algebra chapter 1, which is the set of rational numbers. So it is the set of rational numbers. Set of rational numbers. At the beginning, I want to go back with you to know what are the sets that we studied before in the previous years. Number one, the set of natural numbers. It's the set of natural numbers. This set is symbolized as n like this. And n, it is known that it's like this. See? Double, huh? It's n. It is 0, 1, 2, 3, 4, up to infinity. And it can be represented on the straight line as follows. I can draw it like this. This is the straight line. This is the increasing direction. This is the decreasing direction. Natural numbers start with 0, equidistant, 1, 2, 3. So 1, 2, 3, up to infinity. This is the set of natural numbers. So we can shade 0, we shade the point 1, we shade point 2, we shade point 3, and so on. So up to infinity. This is the set of natural numbers. Don't take the numbers in between. They are not natural, they are decimal. Second set we studied before, it's the set of integer. Sometimes in other countries we say integer. So both of them is correct. It depends on the country that in English native. Set of integer numbers. What's the set of integer or the set of integer numbers? Set of integers, it's look like this. Z. Double like this. This is Z or Z. This is the the set of integer numbers. What is that? It is the same like and exactly the same. So it's 0, 1, but positive. It is also positive, but not right here. Write it here. This is like charge in science. Positive 2 and positive 3 up to infinity. In the other way, we have negative 1. It means losing 1, losing 2, and so on up to infinity. How to represent this on the straight line? Listen to me. These are set of positives. These are set of negative integers. This is 0 neutral. So this is the neutral element. It means has no charge. It is neither positive nor negative. So we have a straight line like this. Listen to me very well. This is the 0. The neutral element has no charge, has no sign. Go right and go left. This is the increasing direction to infinity, positive. This is the decreasing direction to infinity. This is the infinity symbol, negative. We go like this, we increase. We go like back, we decrease. Like this, I gain with the computer in a game. Like this, I lose with the computer in another game. So equidistant. So 1, 2, 3, 4, positive 1, positive 2, positive 3, positive 4, up to positive infinity. Don't stop. Back the same distance. So it's negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4, up to negative infinity. So if you take one positive only, sorry for this, if you take 1, this, and 2, and 3, and 4, if I take from 1 to infinity without 0, they are elements of what? They are the integers or the integers. They are integers but the positive only. So set of positive integers. This quantity is the green one only. Green, 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 green. Don't take this, don't take this, don't take this, don't take any. You can go on the same way. Back, you can take 1, 2, 3 in another color, for example, black. I take black. Negative 1. So this is negative 1, negative 2, negative 3, negative 4. So from negative 1 to negative infinity. So it's the set of negative integers. Wow! So this is a positive integer, set of positive integer, set of negative integers. If make union for them, is it Z? No. Z consists of 3 parts. Set of positives, set of negatives, and the neutral element. I make it with the blue. This is the neutral element. This element is different. This is the 0, neither positive nor negative. Neither positive nor negative. So we can say that Z is the set of negative integers union the set of 0 union the set of positive integers. Good. For example, 3.1 belong or not belong to the set of integers. 0 belong or not belong to the set of integers. Negative 5 Z. Negative 2 natural. I want to complete this question. Is 3.1 belong to Z? Is it an element inside Z? Do you see any number of those? One of them is the, is it one of those? 3.1 here? No. We have a whole number which is positive or negative. So it doesn't belong. So it doesn't belong. 0, yes, 0. Integer. So 0 is an integer. Negative 5, integer. Yes, it is integer. But negative 2 are natural, positive and 0. Because 0 positive, natural means positive and 0. This is negative value. so it doesn't belong. What else? What can we say also? That can I ask about 3 over 4? What's the relation between a natural number? What else? I want to ask about that one. 0 and the set of n. 3 over 4, 3, is it natural? 3 over 4? No, it isn't also. Doesn't belong. Also 0 belong to the natural? Yes, 0 is a natural number, so it is belonging to it. Also, what's the relation between the set of natural number and the set of integer numbers? What's the relation? Wow, we say that all elements here inside Z, every natural is integer. Every natural here, 0, 1, 2, 3, 4, 0, 0, 1, 2, 3, and so on. So n is a part, is a subset of Z. So n is a subset of Z. Or we can say that Z contains natural. Very good. Today I will work, this is previously, today I will work with you this set, this is a new one, this set of rational numbers. The set of rational numbers. Rational numbers, that they are all values. Any number can be written as a fraction, like A to B, so that B non-zero. So B, it is non-zero. Okay? But B is an integer or integer. Also, A also is an integer. For example, what? For example, look, 7 over 9. Is it belonging to the set of rational numbers? I will not write rational numbers. I will write, look, Q like this. This is a set of rational numbers. It's Q like this. Rational numbers and all. We have conditions. 3. Up alone. Up is integer, down is integer, and non-zero. So this is 0? Yes, this can be 0. But impossible B to be 0. So this is integer, good. This is integer, good. And this is non-zero, yes. So it's belonging to Q. Okay, 0.3. Is it belonging to the Q or no? What can we say? Transform it to fraction, 3 to 10. We can transform it from decimal form to fractional form. The numerator is an integer. The denominator also is integer. And the denominator non-zero. So it is belonging to it. Okay? So what's the definition? So we can write Q as follows. How can we define Q? We can define Q as follows. Q, it is all values like A over B, such that the numerator, denominator, both of them are belonging to the set of integers. To the set of integers. Maybe positive, maybe negative. I can hear like negative. This is integer, huh? I can write it here, negative. It's negative. It's okay. -7 is an integer. But as a condition, the denominator impossible to be 0. Take care about this one. Take care about this one. Where we have what? Where 3, for example, over 0. This is has no meaning. Has no meaning. That's why, because here b equal to 0. This is a problem. 3. So this is refused. This is refused. And this is not belong to Q. Very good. Let us go on. As an example, write as a decimal. But we have now a fact. I want to put it first. There is a relation between the set of natural numbers, 0 and positive. They are in the set of natural numbers. This is the natural numbers. If you take with them the negative values, so you have Q. This is the set of rational numbers, Q. Third one, the third one, which is like this. I'm sorry. I'm sorry for that. I'm thinking about Q, but I have to write Z. I'm sorry. This is Z. Positive, negative, positive and negative and 0, Z. Then the last one containing them, so it's Q. So Q is covering all the previous. We can say that the set of natural number is a subset of the set of integers and subset of the set of Q. Why? Take care. If I go back here, look here, back here, this is, for example, 1. I can make denominator divided 1, so it's fraction. 2 over 1, 3 over 1, 4 over 1. Either negative 1 over 1, negative 2 over 1, negative 3 over 1, negative 4 over 1. So it takes the form of A divided B, or A over B. So for example, 7 means 7 over 1. Negative 5 means negative 5 over 1. So this is the form A divided B. Any natural number is inside Z integer, and any integer is a rational number. Let us take some application or problems about that. I have here an example. Listen well. Write in the form you want to write in the form A over B. I need this. I want to write in the form A over B. I want to write in the form A over B. You know this number 1, modulus, or the absolute value of negative 4 and half. Number 2, 0.75. This is number 2. Number 3, 30%. 30%. I need these 3 problems. I write them in the form of a fraction, a numerator and denominator. First of all, the modulus means remove the negative. It means the positive value. The absolute value, Mana, don't look at the sign. So this is negative. It will be positive 4.5 without the absolute value, without the modulus. So write it in the form of A over B. 2 times 4 plus 1. 2 times 4, 8 plus 1, it will be 9 over 2. So it's the same ratio, 9 to 2. I need this area, this, not this one, but this is more. About this, how can we write it in the form of fraction, the simplest form? In the simplest form. This is 2 decimal places, so it is out 100. 75 over 100. Divide up and down by 25, it will be 3 over 4.